I will talk a bit more on how we work in SKF practically, and I will also talk a bit about what we want to do in the future. And I will use very much what we do within machine learning and also what we aim to do within AI. SKF is a product. SKF is a company, and our product is a quite anonymous product. Some of you might have arrived here in a train. We have and are very strong when it comes to bearings and bogies for trains, which we also supervise and ensure that they are in the right conditions so that you don't have a train accident. One or two of you might come here in a bicycle. So it might be that our products are in the wheels to make sure that it spins. I look at you, so I say this with some doubt. Some of you might come here on a skateboard, but I doubt it though. But we are quite good and quite big when it comes to skateboard bearings. So our products are more or less everywhere in your everyday life, even though you cannot see it. So if it rotates, it's a quite good potential that it's an SKF product inside, even if you cannot see it. My focus of today will be more around servitization, not of the product as a steel product that you buy, rather the function that you would like to get out of it, or the service you would like to get out of it. Where we have actually our mission is to increase you, our customers, competitive advantage through what we say sustainable rotation. And we do that through people, planet, profit. For the ones that have worked in production and maintenance, might be some of you, you know that when we have accidents in our factories, on our ships, it's very often related to corrective action, unplanned activities. You have an unplanned, unforeseen activity or action that happens that force you to do something to correct it. What we try to work with is to make your everyday life a bit more boring, actually. It should be no surprises. It should be plannable. You should know well in advance what is about to happen, and you should be able to act prior to it happening and impacting your production, and you should also try to improve it. And then from a planet perspective, I would say a tradition, if we go back in time, has been that you buy a product, in our case, it's a bearing, and you use it, and then you toss it away, and you install a new one. This is not the way we want to run our business. This is not the way we want to change it. We are working with remanufacturing of bearings. So if you have a bearing inside your machine, and you know the condition of it, we can take it out well in advance before it impacts quality, net output, or in worst case, a breakdown. Clean it, inspect it, reuse the surfaces, mount it again, and offer it back to you as a completely new bearing with the same capacity, at the friction of the cost, and with a huge CO2 saving. Because that iron doesn't have to be mined. We don't need to forge it, grind it, turn it, mount it, and then deliver it to you. We are reusing the existing products. If we get the product and we understand this is not good for reman, that we would, of course, recommend you to change it. The same comes with lubrication. Lubricants have been staying in the soil for millions of years. We take it up, and in some cases, companies use it for a year and then toss it away. And we don't think that is a sustainable way of working. So we are actually the biggest lubrication supplier on this planet. So we can filter it, we can clean it, we can reuse it, so that you can reuse what has once come from the soil and make it not a renewable, but you make it last much, much longer. And the last figure is the profit. This should be profitable. It should be profitable for us as a company and you as a customer. And then how we then work with helping our customers to work in this way. We have different types of centers. We call them rotating equipment performance centers. This is centers we have throughout EMEA where we have groups of extremely skilled professionals in different fields. Might it be vibration analysis? Might it be root cause failure analysis, bearing analysis, application engineering? And we monitor and follow the condition of your equipment. And we have quite a few bearings within EMEA connected, cloud-based today. If I were to take everything that is on-prem and handheld measured also, that's the number would be much higher. And then we have 12 different Riemann centers. We opened the last center roughly 1.5 months ago in Kiruna, far up in Sweden. The temperature is slightly different than here. They already start to get snow. Up there we have a cluster of mines and steel companies and pulp and paper companies. And many of them are embracing the Riemann approach. And so we felt with that business potential and that speed that the business is growing, we need to be local at the customer. And we also have a calculation that we provide to the customer. We can prove and show the CO2 savings in having this approach. One of our bigger customers is Billerud-Korsnäs in Sweden. And we actually asked them, so how do you feel working with SKF in this circular way of working, where we take the machines under control? And I will actually share as a 1-minute video and call it a testimonial from a dear customer.
Billerud-Korsnäs Maintenance Department sought help to understand the cause of recurring bearing damage. This led to a technology cooperation with SKF, including bearing remanufacturing services, condition monitoring, application engineering, lubrication, and bearing analysis. The result? Increased flexibility, availability, and getting closer to zero unplanned downtime.
Ja, vi tittar ju inte bara på remanufacturing, vi tittar ju om på hela maskinlösningen. Det driver oss att bli ännu bättre att hitta de kompletta lösningarna för att öka värdet. I slutändan ökar vi kundvärdet, men vi ökar framförallt tillgängligheten på vår maskinpark.
If it would have been longer, I would offer you popcorn prior to the film, but it was quite short. So then how it comes together? Well, we have our rotating equipment performance centers where we have these skilled personnel working in different fields. And we start to look at data from multiple sources. It might be field service reports from technicians being on site doing mounting, demounting, balancing of your machinery. It might be looking at, if we see a deviation, at the stock allowance. So when would we have this product available for you? When would you need to order it in order to have it just in time? Would you need to stock it, or can you order it when needed? And we take this data, we start to integrate it, we start to enrich it, and then we present it to both internally as to you as a customer in different ways. If you are a technician, you probably want to see wide graphs and different data diagrams. If you are perhaps a facility or production manager, perhaps you would like to see the actions coming out of the deviations. And if you are a factory manager or an MD, perhaps you would like to see how many bearings, how much money did I save in bearings I didn't have to purchase versus last year, for example. So we put this data together, and the tools we use today to work with that is mainly machine learning. We are in the beginning of AI, I would say, but we are quite good with machine learning. We are using automatic fine-tuning of alarms. We have auto adjustments of identified defects. We have new thresholds automatically set by the systems, and we have quite advanced diagnostics rules for setting alarms and thresholds. And this is very much automated. So the aim we have had doing this is try to take away some of the trees so we see the forest. As an analyst in the past, you were facing a big chunk of false positive alarms, meaning you spend a big portion of your day closing down alarms that were not actually providing value, but they were false. Now we have more time to focus on the real alarms, and we have a better input of working with those alarms, and we can put together the right set of competences to look at what is this type of deviations we are seeing, what is the remaining useful life before customer need to do something before it impacts quality or cycle time, or in worst case, a breakdown. And the most important, what is the root cause of having this deviation? So not just to mitigate the activity as such, but to start to look at prescriptive maintenance, meaning we start to not just improve it, but we improve the solution prior to you actually seeing and feeling the deviation. Next step, which we are working on, but we are still in a fairly early stage, is to take data from all the different multiple sources we have and all the different databases to work much better with pattern identification. And I will come to an example on the next slide regarding that. And then go into prescriptive maintenance. Prescriptive maintenance is when you, through metadata, identifies a beginning deviation before it actually has started to deviate, and then you correct that deviation and eliminate the root cause of that prior to you actually experience the negative aspect of the deviation. We also work together. We have 2 pilots up and running where we are starting to work with process data. So if we add pressure, flow, temperature, number of pieces, number of ton produced, how can that help us to help the customer to make even better decision and to better and earlier understand the root cause? Currently, we are not in that stage. Now we have a lot of trees. We actually don't see the forest. We are drowning in data. And that's the challenge now, is to sort this data. Which data is showing false correlations? Which data is actually showing the value? And how do we enrich this data and present it so we can actually take decisions on it? And one of the benefits we have, because we have more than 70 factories around the globe, and that used to be my home base. So I have the practice ground, and I have a factory in Gothenburg where I'm located. So what we say when we talk about digitalization, and when we talk about machine learning, and when we talk about AI, first, we set the house in order in our own factories. We don't want to have chaos when we digitalize, because we believe that we will have digitalized chaos. So we get to the point where it makes sense that we actually can do something with the data, that we have some sort of base structure. We have data sorted, tagged, structured. We have repositories to translate so that data from different sources mean the same thing. And it might look like this. We start from a quite, call it decent level, and we go up to what we call world-class level. But we are biased in that we call it world-class. But then you have other countries and factories. This is actually a factory I work myself. This is Tortuguitas in Argentina, where we also had to work. And they had a different, call it maturity of their machine park, much more mechanical. But we actually need to work with what we have. So this is the current situation. It's the same machines. They are painted. Some of them have new covers. We have redrawn their electrical cabinets. We have installed sensors. We have retrofitted quite a lot of solutions. But it's the same machines. So we are quite used to working with old, standalone, single operation machines up to what was in the previous page with automated guided vehicles that serves the machine themselves order the material, and to make that frog leap from this level up to the level we have in Gothenburg. And then we put that, together with our offer. How can we put an offer together for the customer that is fits for purpose? Some cases you want to buy and purchase transactional, we do that. On the other hand, we have customers who prescribes for certain functions that pay us a monthly fee, all included, bearing, surveillance, lubrication system. We work together towards a common target. And then you have everything in between, and I would say that's the big bulk of the customers. What I see as the next slide, and it's the final slide, yeah, is this. And I call it just imagine, because in order for this to be a plan or a strategy or a target, I would need to have everything planned out. And roughly now I have perhaps 60% planned out, so it's still call it a dream. Imagine this, if you're a customer. You get a signal. Hi, this is a robot, by the way. It's not a human. I have auto-diagnosed the beginning deviation. It has not yet impacted quality or output. However, you will need to act within 8 months. You have a planned maintenance stop in 6.2 months, which we know of, where we can intervene. Analyzing 6,200 assets of similar types and trends provide the following root cause: ingression of moisture, insufficient lubrication system. Recommended improved solutions: sealed SRB bearing and a CLP lubrication system. Proposed offer: sealed SRB bearing, lubrication system, and field service technicians to carry out the task. Please press order. After pressing order, planning of work as preparation of material will be initiated. And then solution implemented, documented, root cause eliminated, new threshold defined, we are all go. And to have this fully automated without manual intervention. That's where I want to go. And I believe I will be there in a few years. And that's what we talk about, to reimagine rotation for a better tomorrow. Thank you.
Thank you, Mr. Stieger. It seems, I mean, from condition-based maintenance to prescriptive maintenance, it seems like the holy grail for production managers and product plant owners.